find the number of triplets xyz where xyz are distinct non-negative integers satisfying this condition that their sum is 15. X plus y plus z, this is 15. Now, sometimes in JEE Main, you'll find that there are problems for which you can get the correct answer without actually solving the problem, simply by looking at the options carefully. This is one of those problems. So first we'll see how you can get the correct answer for this problem without actually solving this one, and then we'll see the proper method of solving this problem. So see, the given equation is x plus y plus z, this equals to 15. And the question is that in how many different ways you can select x, y, z so that they are non-negative integer, means they are either positive integer or 0, and their sum is 15. So for example, one possibility will be that let us say x is 0, y is 1, z is 14. Or if you want, let us say x is 1, y is 2, z is 12, and so on. Now remember, here we are talking about number of different triplets. So the triplet xyz is different from the triplet yxz and so on. So if I have one solution as 0, 1, 14, you can get three factorial number of solutions from here by arranging these three numbers. Right, one solution is 0, 1, 14. So next one will be 0, 14, 1. Next one will be 1, 0, 14 and so on. So in how many ways we can arrange this one? 3 factorial. In how many ways we can arrange the next solution? Another 3 factorial. So any general solution you get, let us say there is one solution alpha, beta, gamma, and alpha, beta, gamma, they are distinct numbers. So you can arrange those in 3 factorial, that is 6 different ways. That means whatever answer you are getting, it has to be multiple of 6 only. Now there is only one option which is multiple of 6. 136 is not multiple of 6. This one is also not multiple of 6. Only this fourth option is multiple of 6. And therefore, that should be the correct answer for this problem, right? So this will be the objective approach of solving this problem when the options are given, because our final answer has to be multiple of 6. Only one option is satisfying that condition, and therefore that should be the correct answer. Also, the proper method of solving this one will be that first you can find the total number of solution using the standard formula, and then we can remove those solutions in which all the three variables are same or any two variables are same. So let us say if n1 is the total number of solution of this equation without any restriction. Here the restriction is xyz must be distinct. So first let us find the total number of solutions. So that will be number of ways of distributing 15 distinct objects among 3%, and non-negative means each person can get 0 or more. So 15 plus 3 minus 1, C 3 minus 1. This will be total number of solution without any restriction. So that is 17C2, 17 into 8, that will be 136. So this is total number of solution. Remember, we need only those solution in which x, y, z are distinct. So now there are two cases which we have to remove. One case is where all the three variables are same. X, y, and z, all three are equal. So if x, y, z all three are equal and x plus y plus z is 15, there will be only one case here that x, y, and z, all of them are 5, 5, and 5. And another case that we have to remove is second case when any two of the three variables are same, right? That means x and y, those two are equal and is different from z. Let us take one example, this one, and then we'll see how to arrange those. So if x and y are equal and is different from z, the equation will be 2x plus z, this equals to 15. And now the different values of x that you can take is, it will be either 0 or 1, 2, 3, 4. 5 we cannot take, because if we take x as 5, z will be 5, that we have already considered earlier. So then next one you can take 6, then 7, and you cannot take x as 8. In that case, z will become negative. So these are the 7 different solutions we are getting, right? So if n2 is the number of solution where any two variables are same and is different from z, so one solution will be, for example, x is 0, y is 0, z is 15. Now in how many ways we can arrange these three numbers? So obviously 3 factorial by 2 factorial, right? So corresponding to this one solution, you can get 3 different solutions. Similarly, corresponding to next one, you can get another 3 and so on. So 7 cases. Each one will give us 3 solutions. So that means 7 into 3, 21. So here, if I use that proper method, then total number of solution we got 136 minus there is one solution where all three variables are same, and there are 21 other solution where any two are same and is different from the third one. So 136 minus 22, that will be 114. Right, so that will be the proper method of solving this one. But as I said earlier, that because the answer has to be multiple of 6, only one option is satisfying that condition, and therefore that will be the correct answer for this problem. So the right answer for this problem is option D.